Okay, so what we're doing here is just a simple two-way table where what we're trying to do is put it in so that it is dynamic. What I mean by that is I know that 3 and 10 make 13, so I can adjust that. The problem is that this changes to 12 and now doesn't work. So what we want to do is basically figure out how can I calculate this cell when I know what has to happen here, where I have these two pieces, a 3 and a 13. Well, I know that this has to equal the total minus that value, whatever's there. So that's a 10. And if it's a just, let's say this wasn't suit of cards, but something different, a 15, I can see that that will change as well. So it's dynamically made so that we can adjust values. So the same thing here, I know that this one has to equal this minus whatever is here. That's my sum. And then this has to equal the sum of those above it, right? And then same thing over here. This has to equal the sum of these ones to the side. And then the final one is equals the sum of those two there. And we could check real quick if we wanted to. So I could check by equals the sum of these two. So those again, 52 is 52. So I know that my two-way table is set up and it should be able to shift dynamically. So if I change one of them, let's say that is a 15, everything here should adjust if I change this. So this my 55 there doesn't work because I have this value here. So let me change that back. Sorry, I shouldn't change those. Some here, I should change the ones that are in red. If I change this to be 12, right, everything else adjusts as we go across. I'll undo that. So again, we want to set up something that is dynamic where it's not hard-coded values. And then we can look at what this will look like if I had my green cards here, right? Let's say that I have my heart. These are going to be my sums, and I can go through and work through these ones as well. So we're going to get down here to look at, this is our probability. So how do we use our two-way table to change our probability? Well, this is going to equal my number of hearts divided by my total, which is that. And then for my heart that's not a face card equals this divided by the total. And so you can see that I have a 25% chance of getting a heart, which makes sense because there's 1 in 4 of those suits. This one for a non-heart equals my non-heart divided by the total. And this one is going to be a critical one because let's hope if we're getting it right, is going to equal the non-heart divided by the total. There we go. So they all add up to 1, which is what we want to see because that means it's 100% of our values. And I can see the probability here of a non-heart is about 17%. The probability of a non-heart, non-face card is about 57%. The probability of a non-face card is almost 77%, and the probability of a face card is about 23%. All right, if we're looking at for not these, right, a face card and not a heart, so this is going to equal my face card and not a heart, we would have to use those values up here to figure that out. So if I'm looking at the probability of a face card and not a heart, right, I know that the probability of a face card, right, minus not a heart would really be this one here. So these are my face cards that are not a heart. There's different ways that we could get to that though, where it's the probability of a face card minus the overlap, the face cards that are not hearts. So that would be these ones. And that again leaves us with this value that's here. So the probability of not a heart or a face card, right? So it can't be here and it can't be there. That should be this value here. So the probability of it's not a heart, so it can't be on this side, right? And it's not a face card, it can't be there. All we're left with is this value here.